Hello and welcome to another SAS Viya tutorial. My name is Antti Heino and I work at SAS Institute as an AI advisor. And today I'm going to show you about SAS Studio and its flows capabilities, and especially on how to prepare some data, build machine learning models, score new data with that model, and register that model to a centralized model management repository. Okay, let's get started. You see here the interface of SAS Studio, and we are gonna launch a new flow. So let's click that one. And what I want to do in this case, usually maybe you would have a database connection, but in this case I want to import a traditional CSV file. So I'm gonna drag that CSV file from my server file system, and I want to import that file. So we have these ready-made steps here that we can use to do different things on the data without any coding. So I'm going to drag and drop this import node to the canvas, and I'm going to analyze the data. And it's analyzing the columns and generating a preview for me. It looks good, so I'm ready to assign a table for it. So I'm going to drag and drop a table node for it and select a library. So I'm gonna just put it in my personal CAS user library and give it a name. All right, let's call it HMEQ2. All right, I'm gonna run this node. All right, I should have the results now in my CAS library. And as you can see, we have the HMEQ data now in memory in our CAS user library. Just to keep track of things, let's do some swim lanes here so that we are able to organize our work. So let's call that one import, and let's create a second swim lane. So now we want to start analyzing our data. So I will grab now the newly created data and drag that to the swim lane. So first I could, if I wanted to, I could maybe do some data quality and do a filter. And in here I want to select all the data. So in this case I'm building a credit scoring model with this data. So I want to make sure that the house values in this data are all greater than, let's say, 1,000 units, so that there isn't values that are too low for my purpose. And I can just run the node and get the results again. And in each of these nodes, I can preview the data after the submission by clicking the output port and checking out the preview data from here. So now I shouldn't see any values below 1,000. Looks great. Let's get going forward. Next, I might need a ID column since there isn't one in this data yet. So I will use a SAS program. So you are able to use any type of SAS code here in addition to these ready-made steps. And I can copy and paste, for example, you can easily find this type of code on Google that creates a ID for you. But in this case, as you see here from the code, I'm using these macro variables. So I'm using the input one that refers to the node's input. And you can actually see it here in the node details that there is this macro variable one that you can refer to as the input data set. And then I'm just assigning the out to the output one data set as well. And I can run this and get the results again. Okay, looks good. Now I have an ID column for all the rows. In addition to SAS code, I could also use Python programs here. So let's do just one as an example. Let me just copy and paste some code so that I don't have to write everything. So depending on what kind of packages you have installed, but yeah, you can run any Python code you have packages for. So in this case, I'm just doing, yeah, like a very simple example of some data preparation. Just let's run this and you can see how it works. Okay, the program runs and I can see the new data set. So here is the new data set that was created by this Python step. So you're able to integrate Python code in this data prep as well if you want to. Okay, so the next steps I'm going to show you, we really don't need for the analysis, but I really want to show them because they're really useful and you might need them in your projects. So I'm going to grab the Manage Columns node here and connect it. And then I'm gonna see the columns available. And I can select, for example, the ID column and my target column, which is the bad. So whether the applicant has defaulted on the loan or not. I'm gonna add those for my output table. And I'm able to run this node now. And as we can see from the results, we have only now the ID and the target column left. And we can do the same for the input data. So I will select everything else than the ID column, like this, and run the node again. And now I have split my data into two sets, so the inputs and the target. And if I want to join data, I can use this query node. So I just wanted to show basically this just to show you how you are able to join data. So in this case, I want to add an input port to the query node, so I can connect the other one as well. And here I can set some join conditions. So here it has automatically detected that there is this ID column in both tables, and I will do an inner join of those tables. And then I just select the columns I want to use. So I want to use all the columns, so I can drag and drop those to the template, and then I'm just gonna remove the second ID column since we don't need that one. All right, I think that's it. Then we can run this node. Let's look at the results. So now I have my data joined back again, so I could continue working on this. And if you have more data sources, yeah, the query node is your friend here. If I would like to create new columns, I can use the query node also for that. So I can do a calculated column here. And if I would maybe just for example, like to create maybe a percentage of the loan compared to the house value, I could do easily a column like this and give it some type of name and just assign its type to numeric. Okay, easy as that. I can save this column. And this is one example, or then you can just create your new columns using Python or SAS code, obviously. And let's run this again to get the calculated column in the results as well. Next, we need some type of partition to the data, so we are able to create our machine learning models. So for that, if you see the steps, there isn't a partitioning step here. We could do it with just coding, but if you don't want to code, there are these tasks we can use as well. And here we can find a partitioning task in here. So let's click that one. And just make sure when you are selecting tasks, whether you are using the Viya tasks or compute node tasks. So basically any of these folders that do not have Viya mentioned, because those are running on the compute server and not on the CAS server. And you soon see why that's important. Okay, for the partition, we could do a stratified sampling and stratify by, let's say, for example, our target variable, and then do 3 partitions and set maybe 60% for the first one and 30% for the second one, and then the remaining 10% will go to the last partition. Then we need to select the output data. So as an example, let's write it in the CAS user library. Great. And after I have made all my mandatory selections, the code generates. And now I can just click this code to flow button here, and it will take the code that has been generated to the flow. And here I get my new code, and I can just connect the previous step into this program node. But now I have to take care of the fact that I want to run this on the CAS engine and not on the compute engine. So I just want to transfer the data from the query node, because it's outputting the data into my work library, which is a compute library. And I just want to move that data into my CAS user library, as that is a CAS engine library. And to do that, I will use really simple code you can use in every one of these situations. So basically what you need is just this little data step. So you are referring to the input 1, so the node's input, and you are moving the data into some type of CAS library. So in this case, I'm just using my CAS user library and creating a temp table for this purpose. And then I'm just changing the reference of this proc to the temp table that I'm creating in this step. Okay, now it should run. Let's try. Perfect, it's working as expected. So I see my temp table here, and then the result of the partitioning. And I can now drag and drop this table to the flow as well. Now I might want to check whether the partitioning is correct. So let's do a simple bar chart visualization. And again, if I don't want to code anything, I can just move to the tasks and select here a bar chart task and use that one to generate the code. So in this case, we want to use the partition data and do a bar chart. So let's select a category. So we want to see how the partition is created. So select that one as the category, and let's select the target as a subcategory, just to make sure that we have the target cases also in each of the partitions. Great, now we have the code ready, and we can just push this button again to get it to the flow. And we can just use the data and connect these ones and run the node now. And in this case, it's a visualization, so we can see the results from the submission tab. And yes, we see that we have successfully created a partition for the data. Great. Now that we have our data partitioned, we are ready to build our machine learning model. And for that, there is a task for that. And in here, in SAS Viya machine learning, you can find various algorithms. So let's try gradient boosting this time. And in here, we are all, again, able to make the selections we want and generate the code for our gradient boosting model. And in this case, we want to use validation data for our model. I select the partitioning variable, which is our partition indicator, and then select the values for the partition. So for validation, we will use 1, and for training, we will use the partitions 0. For the target, we are using a nominal target of bad, so whether the applicant has defaulted or not defaulted on the loan. For interval inputs, let's select some inputs that could be important, like the number of credit lines, the credit line age, the debt to income ratio, number of delinquent credit lines, for example. And let's also select a couple of nominal inputs, like the applicant's job type and a reason for the loan. Great. Now we have the mandatory fields finished, but let's look at the other options. So I could do auto-tuning of the model parameters here as well if I wanted to. I could also do some interpretability visualizations if I wanted to have those in this case. Let's still select some of the outputs. So we want to have the scored data saved. So let's select the table for that, and we want all variables to be there. And yeah, let's put it in CasLive, and give it a name. And in the same way, I want to save the scoring model in case I want to score new data. So I will just save that model to the CAS user library as well. Perfect. Now I have the code created, and I can move it to the flow. And I just connect this to the partition data, and I can run now the machine learning algorithm. So now the algorithm is looking at the historical data and trying to determine what are the differences in the input variables compared to the different target groups. So the good applicants and the bad applicants. Okay, our model has trained, and next we can look at the results. So we have the score data here in the result table, and we can connect that to there. And finally, we can use the assess task. So let's use that one. If I want to now see some ROC curves or lift charts, for example, I can now use the assess method or the task to generate the code for those. So I will want to use the results table. I just assign the target, which was bad. I select the event level and the posterior probabilities. Great, now I have the code again, and let's take it to the flow. Connect the nodes again and run the node. So in your case, there might be more models you want to train, so you can just use some macro variables in the assess code to assess many models at the same time. So depending on your situation, feel free to modify the assessment to a way of your liking. Okay, but here we see how the model accuracy has behaved. We see like the true positive information, the aux, Ginis, and so forth. and also the ROC curves and the lift charts. The model looks good for this demo purpose, so let's get forward. Okay, I think we are ready with the training, so I will just name the swim lane, and we can move to the next one. So this next one, we're going to do some scoring. So let's get some new data and score that through our trained model. So if we now have new customers applying for loans, we can use now this trained credit scoring model to understand the new customers' creditworthiness. I don't really have new data here, but I will use the same partition data, and we're just gonna grab the test set of the data and score that through the model. And for that, we can use the filter rows, step, and connect those. And here we see the variables again, and we are going to use the partition indicator to filter the data. And in this case, we want to do a equal to filter and select the right value. So we can use this one to get the values of the data and select 2, since that was the test set of our partition, which the trained model hasn't seen yet. And we can now run the filter to get the right data we want to. Great. Let's just make sure from the preview data that it's working as expected. So here now we see that we have only partition 2 variables in the data. So finally, we have to score that data, and there is a task for that as well. So we can select the scoring task and then select the data we want to use. So basically it doesn't really matter as long as it's the HMEQ data, because we can't change this one. But let's select something as close as possible and then use a saved scoring model. So we saved our model to this HMEQ2 credit boosting model binary file. So we will select that one. And then where we want to get our output data. So let's put it in the same CAS library and give it a name. For example, scored is fine. Okay, great. Now the code is ready and I will put it to the flow. And here we have the scoring node. Great. Now just we need to remember that again we are working now with a work table that is in a compute library, and now we want to do a scoring task using the CAS engine. And yeah, we're gonna just grab the where was it? It's in here. We want to use this little helper code just to get our data in the right place. So we will use pretty much the same thing. So that this is what I'm talking about, where that I'm able to use the same code pretty much everywhere after creating it once. So we're gonna change this this code now to just the temp file 2. And we want to use the same output still. We are referring to same model. Okay, now it should run. Great, the run is now finished and I can see the results in here. So I have now the score table of my data, and yeah, here I can see the results of my test set and all the scored customers. So based on these results now, I could grant loans to the good applicants and decline the bad applicants. Okay, our final task would be to register our trained model to centralized model management in case we want to use that to deploy the model to a real-time application, or maybe deploy it to a batch scoring job if I want to. So as you might have guessed, there is also a task for that, and there is this register task that helps me with this thing as well. All you need to select is your model, give it some type of a name. So let's say HMEQ2. I don't really need to provide a description. I just need to give the project name where I want to register it to, and the code is ready. And now I can take this to the flow again and have that as the final phase. Great. Let me run this, and that will take and register the model code to the centralized model management repository where we can follow its performance if we want to deploy it to production. Finally, I will briefly show you the model where it went. So if I go to model management and select the project I have created, I should now see the model I just registered. So yes, we have the credit boosting model we just registered from SAS Studio. So now we see it in model management, and now I could publish it to any cloud container or any engine I want to. All right, hey, thanks for watching. Hope you enjoyed this video.